Hello everyone, how are you doing? Welcome to an algebra tutorial video learning about how to factor polynomials. In this case, we're learning about how to factor polynomials using multiple steps until they're factored completely. All right, let's take a look at this example. What do we have going on here? We've got 32 times a to the 6 times b squared minus 2 times a squared times b squared. All right, it's a big mess. It's a lot of variables, a lot of kind of weirdness going on. The first thing I want to do though, number one, factor the greatest common factor. I want to clear everything out that I can out of the way. So let's take a look at both our terms here. What do we have in common? Between 32 and 2, I can factor out a 2. Between a to the 6 and a squared, they have two a's in common, or a squared in common. And between b squared and b squared, they have b squared in common. So there's quite a lot that I can pull out and separate. Let's rewrite this whole binomial now. And we've got 2 times a squared times b squared. And what do we have left? 32 divided by 2 is 16. A to the 6 divided by a squared is a to the 4th. B squareds divide out. So we got minus 2's divide into 1, a squares divide into 1, b squares divide into 1, so it just leaves just 1. Alright, so that kind of made things a little bit simpler, factoring out the greatest common factor. What do we have left now? So I've got two terms, so it's a binomial, so now I'm already limited in what I can do with a binomial. So with a binomial, I can only factor it if it's the difference of two squares, the sum of two cubes, or the difference of two cubes. Let's see what's going on. 16 is 4 squared. A to the 4th looks a little tricky until I think about a to the 4th is just a squared squared, and then 1 is something squared. So I have the difference of two squares here. So I'm going to go ahead and write that. My second technique, or my method I'm going to use, is difference of two squares. Difference of two squares. And I'm going to rewrite it just so you can see it's two squares. So 16 is 4 squared. A to the 4th is just simply a squared to the second power. So there's something squared, minus 1 squared. And we've still got the 2a squared b squared in the front there. So the difference of two squares, if you remember, I can rewrite as a minus b and a plus b. So let's go ahead and do that in this case. We've got 4a squared minus 1 times 4a squared plus 1. And we've still got 2 times a squared b squared in front. All right, nice job. So again, we can get back to it. 4a squared times 4a squared gives me 16a to the 4th. 1 times 1 gives me the 1. Because it's a negative and a plus, my middle terms are going to cancel out. So as you're factoring, just mentally go back through, multiply, factor, multiply. Check your work as you're going through to make sure things are working. All right, are we done? Ooh, we are not done. Let's check what we have. So we've got two more binomials, but they both have something squared again still. I can only factor if it's the difference of two squares, but right here I've got 4a squared minus 1. That's the difference of two squares. I can rewrite that as 2a minus 1 times 2a plus 1. Right? 2a times 2a gives me 4a squared. It's a negative and a plus, so my middle terms cancel. Negative 1 times positive 1 gives me the negative 1 right there. So yeah, it's factors. We actually have to use this difference of two squares twice, which is why I wanted to go over this example with you guys. I still have the 4a squared at the end there, plus 1. I can't factor that because it's the sum of two squares. And I don't have any method. There's no way to actually factor this out. And I also still have the 2a squared b squared in the front. All right, so what did we get to? Let's write out my total complete answer. All of this original binomial that I started with, factors nicely into 2a squared b squared, the greatest common factor. We have a factor of 4a squared plus 1, that one binomial right there. I'm just rewriting the order a little bit differently. And then we had two factors. We had a 2a minus 1 and then another factor of 2a plus 1. So our original binomial actually turned into 3 binomials multiplied plus a monomial in the front, a common term. So a complicated factoring job in which we had to use the greatest common factor and then use the difference of two squares twice to factor it as far as we completely could. Hopefully this is helpful for you guys as you're working, again, trying to apply multiple factoring techniques and break a polynomial down into as many little factors as possible.